Okay, folks, we're going to work on our Chapter 1 test review, and we have, going back to points, lines, and planes here, the first question is to name plane P in a different way. So plane P can be labeled with this capital P, or it can be labeled with 3 points. So I have plane P up here. You see this capital letter that we have labeling it. I can also label it as plane A, B, and D, as long as the 3 points that I pick are non-collinear. Okay, so I can pick points A, B, and D, and that'll signify those 3 points are in the plane. Obviously, I don't want to use F. I don't want to use G. They're not in that plane. I also wouldn't want to use A, B, and C because they're collinear, and I really wouldn't be able to tell if I was talking about specifically plane P. Okay, it could be many other planes that run through that same line. And don't forget to notice here that this is line M, right? And this is line L. I can use 2 letters to signify a line, or I can use a lowercase script letter. Okay, so for a plane, I can use 3 points, or I can use that capital script letter as well. Okay, so next we want to name line M in a different way. So remember, we started with points, and then we graduated to lines, and you need 2 lines, or 2 points rather, to name a line. So line M in a different way, we could call that line DB. And put that line symbol over there. Okay. Or we could also call that line BD. Right? When it's a line, it doesn't matter which way we're writing it. Now in number 3, it's a little bit different. We've got ray CB. Okay? So if I name ray CB in a different way, I have to start with endpoint C. Okay? Ray CB goes this way and it runs through B. So we start here and it runs through there. So I don't want to use B, but I could use A since it goes on infinitely. So that could also be ray CA, would represent the same ray. Okay, so go ahead and try number 4 on your own. Okay, so hopefully for number 4, for ray AC, you started with the letter A, but instead of using C, maybe you used B to run through in that direction. That would be a correct answer. Okay. Name the intersection of plane P and line FG. Okay, so I have plane P, that's the only plane that we really have drawn here, and line FG sort of runs vertical. You can see it up here, and it runs through the plane. Now, this dotted line over here, that's sort of like my X-ray vision. I'm looking through the plane. So F comes down, it's like up above it, hits a point E, and then runs through it. So the intersection there would be point that would be point E. So I use my point symbol. And that's point E is the intersection of plane P and line FG. So the next one's a little bit different. Intersection of plane P and then the line DB. Well, DB lives in that plane. So we could just simply say that DB is the intersection of it. Okay, where do they intersect? They intersect anywhere you're on that line DB, you're still living in that plane P. Or I suppose we could say line M. So DB or line M. For some reason, when I make some of those symbols, it automatically zooms in. So I am not going to do that again. Okay, so now we're going to talk about collinear and coplanar. The first question here, are E and D collinear? Well, without even looking at the picture, really, I ought to be able to tell that they are indeed going to be collinear because it's just 2 points. So I can say, even without looking at it, that there must be a line that I can use to connect those 2 points. So I would say yes to that. Okay. Are A, B, and F collinear? Well, now we've invited a third point to the party. So here's a B, okay? And clearly we now can see that F doesn't live on the same line as those 2, so that is a no. Okay. Are A, C, and F coplanar. So let's take a look at this one carefully. AC and F. So here's AC, right? Now they're certainly not collinear, because they're not on the same line. But if I can envision a wall that kind of goes diagonally across this box, stop blowing up. What about this wall here? We'll see how good I can draw it. And I'll try to shade it in so you can sort of see 3D. Okay, sort of a wall that goes diagonally. Like suppose this was a room and I wanted to split it in half across a diagonal. You can now see this plane ACF, so they would be coplanar. We can say yes to that. Okay. Try number 10 on your own. Okay, so number 10, take a look. GH, you know they'll be coplanar because they're collinear. What happens when B gets involved? B is up here. So can you picture a plane that if we went from the corner of across one ceiling and then sort of a corner across one floor and go diagonally again, we should have said yes, they are coplanar to that. Okay, so that is a yes. Okay. All right, name the intersection of CG and GH. Well, even without looking at this, it should be obvious. We have a line, okay? And the intersection of two lines ought to be a point. So here goes CG. Here is GH. Their intersection would be point G. Okay. All right. Name the intersection of plane CGD. Okay. So CGD, that's the floor plane there, and plane BFG. Okay. So we're looking at CGD. This is the floor here. So here's CGD, right? That's the floor plane. And plane BFH, that's this wall. So where do those two intersect? They're going to intersect along here, line DH. Okay, try number 13 on your own. Okay, so now we're on to the back of your worksheet here. We have linear measure. And I'll look at the first one with your measuring in centimeters. So if you notice with centimeters, we're dividing up each unit into tenths, right? So there are 10 little hash marks from one whole unit to another. So I'm here, this segment MN is clearly 3 centimeters long, but then I go 1, 2, 3, 4, 5 more tenths, or actually it looks more like 4 tenths, okay? So this would be 3 and 4 tenths, or more simply 3.4 centimeters. Okay? Try number 2 on your own. Okay, so number 2, now we're in inches, but notice the inches are divided up into 16 pieces from one to the next, right? I have 1, 2, 3, 4. So right here I would have 1 whole inch, but then I have 4 sixteenths, okay? Or this would just be 1 1/4 inches. Or 1.25 inches if you like decimals better. And I'm having trouble with this pen. Keep zooming in. Don't want it to do that. Okay, so sometimes we have to use segment addition, or we use our concept of segment addition to find a piece of a segment. So here I want to find the length of RT. Well, RT is going to be composed of RS plus ST. I can tell when I look at that segment RT equals RS plus ST. Okay, so that's the first thing I'll write. Over here, I'm going to say BC equals AB that's AB. So stop zooming. Try it again. AC equals AB plus BC. It's BC. Okay? So in both of these, we want to solve for the unknown. So if I wanted RT over here, it's RS plus ST. Over here, I have to do something a little bit different. Here I have AC as 6. So here in number 4, I know that AC is 6. That's the whole piece. So that equals AB, which is 2 3/4 inches. Okay, 2 3/4 inches plus my unknown piece BC that I want to solve for. Okay, so I'll let you finish these two on your own.